Hello everyone, today I'll be solving two-sum problem, and in this video first I'll do is read and do a dry run of this problem, and then I will go over O of n squared time complexity solution conceptually. Lastly, I'll go over the most optimal solution, which is O of n time complexity solution. I'll do the both conceptual and the C++ implementation. So let's get started by reading the problem first. We are given an array of integers nums and an integer target return indices of the two numbers such that they add up to target. So what is saying that we are given an array nums, and if my nums I plus nums j is equal to target, the sum is equal to target. That means we have a valid pair of I and j, and this is my answer, I comma j. And we are also told that we can assume that each input would have exactly one solution, and you may not use the same element twice. By that means, they're saying that I cannot be equal to j, right? So, and if you now I'll go over a example that I have already written for you guys, and which is this. Let's look at this nums array. We are given the elements 11, 2, 15, and 7, and our target is 9. The elements that actually satisfies this condition is 2 plus 7 is equal to 9, right? And the index number of 2 is 1, and the index number of 7 is 3. So for this example, my solution set is 1, comma 3. And now I'll be explaining what did they mean by you may not use the same element twice. Is that my I cannot be equal to j. Let's say my target is 14 for the same example nums. And if I look at this, 7 plus 7, so I have the same index, which is 3. Here my I and j is equal to each other, and this is prohibited, and this is not reasonable for this particular problem. So I hope you guys understood the dry run of the problem. So let's talk about how we can solve this problem by coding it. So the first step would be going over a brute force solution, which is O of n squared solution. So let's talk about this. If you look at the problem, this particular example that I have written, on top of that I have also written the index number, so I'll just copy and paste it here just for the sake of easy visibility. So if you look at this, for this particular example, our target is 9. But we do not know which pair of indexes that satisfies. So in code, we will do is generate all the possible combinations, which is 11 plus 2, 11 plus 15, and 11 plus 7. And each time we generate this combination, we will do a check if this satisfies this condition. If this satisfies this condition. So in order for me to generate all these possible combinations of I and j, we usually do is run a two for loop where my I will start from 0 and I is less than n, and the second for loop will be within the first for loop where my j will start from I plus 1, and that is because my I and j cannot be equal to each other, and j will be less than n. Well, inside that for loop, right, since we're done creating one possible pairs, we will do is check this condition inside this for loop. And if this for loop satisfies, then we have our desired solution I comma j, and then we can close the parentheses. And this is how we will generate all the possible pairs, and while alongside generating, we will be checking this condition to see whether it equals up to the target, the sum equals up to target, and if so, then return my valid pairs of I and j immediately, since we have only one particular solution. And if not, it runs through all the for loops and eventually just returns an empty array. Okay, so now that we have understood the brute force solution, let's talk about the optimal solution, which is the O of n time complexity. And in this particular solution, we'll be using the concept of Hashmap. and rearranging the equation. Rearranging the equation. In this case, our equation is this. Copy and paste it. Our equation is this. And I'll just rearrange the equation first. And then when I do the dry run, you guys will understand what I'm doing. Target minus nums I. So let's start doing the dry run of this algorithm, and then I'll write the pseudocode. So if I do not do a dry run, then you guys will not understand what I'm about to do and why the hash map is important in order for us to find a linear time complexity and time space solution, right? So let's say we have our hash map here, and I'm just gonna copy paste this example again. Copy and paste it right here. We have our design hash map. So what the hash map would work in a way for us to find the desired I and j value in one single linear time space and complexity. So in our hash map, our key is the index, and my nums I, and our key is nums I, my mistake, nums I, and the value of the key would be the index. So let's start off my I from 0 at 0th index. When my I is 0, I do this. I try to find if the nums j exist in my hash set or not. So I'll do is my nums j, and then my element is, my target is 9 minus my nums I, which is, in this case, is 11. And I'll do like, oh, it's -2. Is -2 exist in the hash map? Currently, it's been empty. So I can say, no, it does not. After that, after checking that condition, I'll insert my current nums I, which is, as my key is 11, my index is 0. And then at index 1, I'll do 9 minus 2 is 7. Does 7 exist in my hash map? And we can say, no, not yet. Therefore, we'll go again and insert my 2 and index 1. Now, when my I is at 2, index is 2, I check again. 9 minus 15 is -6. Is -6 exist within the hash map? And it seems like not yet. So I'll go again, put my nums I as my key, which is 15, and its value would be the index of 15, which is 2. Now at index 3, I'll be like, okay, 9 minus 7 is equal to 2. Does 2 exist in my hash map? And I can say yes, it does. Then return. Since it exists, then we just return our hash map of nums_j, hash map of 2, which will return the key, return the value of index value, which is in particular case 1, and return the current index I immediately, right? And that's because this works, because if you look at 7 plus 2, it gives me my desired target value 9. I hope this dry run makes sense. So let's just let's just do a pseudocode for this before I even start implementing the solution. So the pseudocode would look like something like this. First, I'll generate for loop, which is for I will start from 0, and I will run before until n. And here I'll be like, my int nums j is target minus nums I. And now in the if statement, I'll check if nums j exists in hashmap, then return the index, then return the pair of index that actually satisfies. In this case, I'll say hashmap of nums j will give me my key, my index value, my mistake, not the key. Nums j works as a key. This will give me my index, and I'll return my I. If it iterates to all the and all the nums index, then and we still couldn't find our one solution, then it'll just return an empty error. I hope this makes sense. And now I'll just jump into code implementation in C++. Now I'll run my optimal of n solution for two-sum. First, I'll declare my hash map, and my hash map container will be the unordered map. My first int is nums I, and then my second key is the index. That's how it'll store the values for me. And I'll call it as a hash map. And now what I'll do is iterate through the nums array using a for loop, where my I will start from 0 and run until n minus 1, because since it's a 0-base index and I plus plus, my n is the nums dot size. Here I will solve it for nums j, so I'll declare the variable nums j is equal to target minus nums I. Now I'll check the if condition to find whether nums j key exists in the hash map or not. Check nums j key exists in the hash map or not. Here's my if statement. I'll say hash map dot find nums j hash map dot end. This is how we check in C++ whether the key exists in the hash map or not. If it exists, then return the key's index, which is hash map nums j. This will return the index, our I, and then this is my I for the current nums i's index. Otherwise, it'll keep inserting in our hash map the value, which is this current nums I, the key, and the value and then its value I, which is the index. And after iterating the whole for loop, if there's still no solution, then it'll return an empty array. In this case, it's a vector in C++. And now let's compute the time complexity before I even run the code in this platform. PC is big O of n, since the for loop runs n time. And the lookup time complexity is O of 1 in unordered map. Insertion also takes O of 1. And my space complexity is O of n, worst case scenario. Overall TC I can say is big O of n. And space complexity is big O of n. Now let's run this code. So it works. And first try, that's good. And let's see if it passes all the test cases or not. So it seems it passes all the test cases, and it pretty much beats all the other submissions too. So I hope that's it for today. And I hope all of you enjoyed my video two-sum problem and understood the whole concept behind using the hash map for this particular problem and how I derived it to optimal solution. And if you guys still have any particular questions or confusion, please feel free to leave a comment in the video, leave a comment in the video's comment section, and I'll be more than happy to get back to you guys. Thank you.